guys, welcome to lesson 721 day 1. Today we are just going to take some time to refresh on something we learned last semester because it's going to kind of be used in something we're going to do in this unit. So we're bringing back transforming parent functions of graphs, but we're just going to focus on parabolas just so that we can get the hang of working with a, h, and k again. So if you remember, we always had a graphing form of these functions, and it was a times x minus h squared plus k, where a was in charge of the stretch and compression, h was the left and right movement, and k was in charge of vertical up and down movement. And also just to keep in mind that if there was a negative sign up front, so if a was negative, there was a horizontal x-axis reflection. So at this point, we are just going to go ahead and draw some of these transformed graphs. We're working with the parent function y equals x squared, and we're just going to do like one at a time. So if I had y equals negative x squared, I can see that there's a negative sign right in front of my equation, and that tells me, just like we talked about up here, that there is a reflection. So we're going to list that there's a reflection. All right, and that means we're going to flip our graph, and that's really all that we're going to do here. So if we know that it's not going to move anywhere necessarily, this locator point isn't going to go anywhere, we're really just going to reflect over the x-axis. So this point stays the same, but these points have to maintain their distance on the other side of the x-axis. So this first point is one box away from the axis, so we're going to go 1 in the other direction. This is something you guys learned how to do back in geometry. This point is 1, 2, 3, 4 away, so I'm going to go 1, 2, 3, 4 in the other direction. This point is also 1 away, so 1 in the other direction. And of course, parabolas are symmetrical, so you don't even have to do much work on this side. You can just be level with the other side. And once you've done that, you've completed your transformed parabola. And that was the only thing that was going on with this one, so you're done. All right, this next one is x minus 1 squared. So here there is something going on in the parentheses, and if we go back up to our graphing form, that's going to be our h. So h is in charge of left and right movement. So it's really important that you remember that h is obnoxious, and it does exactly what you wouldn't expect it to do, meaning if there's a minus in here, you're going to move to the right. If there's a plus, you're going to move to the left. I know it's not what your brain would necessarily assume, so you got to make sure you keep checking yourself when you're doing that. So this minus 1 indicates that we're going to move to the right by 1 unit. So now that I know that, all I got to do is take all of these points and scooch them over 1 box to the right. So this one's going to move over here, this one's over here, this one's over here, and I'll go to the left ones. This one moves over 1, this one moves over 1. So this is then my transformed graph. And that is my final product. All right, my next example is x squared plus 3. So if we look back at our graphing form, that plus 3 is on the outside. There's nothing inside of parentheses. There's nothing in front of the x. So that tells me I'm working with a k, which is moving me up or down. So if my 3 is the k, that means I'm moving up 3. And unlike h, k does exactly what you would expect it to do. So plus does indicate up, minus does indicate down. So I'll take all of these points and simply scooch them up 3 boxes. So this one will go up 1, 2, 3. This one will go up 3. This one will go off the graph a little bit. That's all right. Like 1, 2, and that's about where it'll be. The other side, you can just follow symmetry, or you can scooch these up individually as well. And so that is it for this one. Okay, and that is our final product. So this last problem is a little bit trickier. Now I have multiple transformations going on, so it's really important that we list all of them and kind of go step at a time. So the first thing that's worth noticing is that there's a number out up front, and if we look back at our graphing form, that number is going to be our a, which means it's in charge of stretching or compressing. So the way you can tell whether it's a stretch or a compression is just based on the size of the number. If your a value is greater than 1, that's going to be a stretch. If your a value is less than 1, that's going to be a compression, and that's when you get into the decimals and the fractions. So here, because my number is 2, that tells me that we are stretching by a factor of 2. All right, next in line we have this plus 1 in the parentheses. That's going to be an h. And h is responsible for horizontal movement and its opposite. So plus 1 in the parentheses indicates that we are moving to the left by 1. And finally, we have a minus 1 on the outside, that's our k, and that tells us that we are going to move down by 1. Okay, so when there's like a lot going on, you have to be careful about what you do when. It's always good to take care of the stretch or compression first. When we did this unit in the first semester, we did not graph stretches or compressions. I did not make you do that. So that is one little thing that we are adding on here, but it's not anything too crazy, and we're really only going to work with stretches, not compressions in this case. So the first thing we want to do is take care of the stretch, and then we can move it wherever we want. So when you're stretching your graph, it's not necessarily moving, so this locator point won't go anywhere. It's these other points that are going to change. So what you want to look at is the change from the origin to this first point. You go right 1 and up 1. Now since we're doing a stretch, and it's a vertical stretch, and the factor is 2, we need to double that vertical change. Since here the vertical change is 1, we need to double that and go up to 2. We don't move anywhere horizontally though. That's the wrong color. All right. And we're going to do the same thing for the next point. So since this one from the beginning is right 2 up 4, we want to focus on that vertical change of 4. Because our stretch factor is 2, we want to double it, and instead of going up 4, we're going to go up 8. And I know that goes off the graph, but it's going to go 5, 6, 7, 8 is going to end us up here. On the other side, remember, we can just maintain that symmetry. We don't have to work super hard on that part. So now I've stretched my graph. I'm going to go ahead and draw it in. But I'm not done. I still have 2 other transformations that need to take place. This is really ugly. So now I need to move it left 1 and down 1. Now luckily that we can actually go ahead and just do all at once, so we don't have to do that in 2 separate graphs. We'll just take every point and move it left 1 and down 1. So we'll go left, down, left, down, left, down. Kind of imagine with this one. Good enough. Do the same on this side. And then we can draw our final graph. Yeah, sorry, these skinny graphs are coming out pretty ugly. All right, and then this is our final graph. All right, and on MyOpenMath, you really only need to click the vertex and then one other point for it to graph the entire rest of the curve. So you don't have to worry about more than 2 points anyway. But that is all for today. Tomorrow we will talk about transforming sine functions.